Everyone knows exercise does a body good. But what effect does it have on our genes? This exercise machine will help answer that question. The volunteers train here 4 times a week over a 3-month period using only one leg.
You can try a little bit faster.
For Malena Lindholm of Stockholm's Karolinska Institute, one thing is key. The volunteers will exercise one leg during the test period. The other leg isn't trained at all.
Okay, looks really good, Mark. So you know the reason we're doing this one-leg training is that both your legs have the same genes. They experience the same diet, the same stress, the same sleep. It's only going to be the training that differs. So we can then use the other leg as your own control.
If exercise really does alter our genes, that might also help explain its health benefits.
We all know that it's good to exercise. There are so many health benefits of training, like you reduce the risk for many of our most common diseases, like type 2 diabetes, obesity, cardiovascular disease, different cancers. But we don't completely understand the mechanisms behind these health benefits. Okej, nu kommer jag ta biopsin.
To examine and compare the genes, the researchers take a small sample of muscle cells, one from the exercised leg, one from the one that wasn't exercised. The researchers examine the DNA from the muscle tissue biopsies for any biochemical changes, focusing on the regions that regulate the genes. The results revealed a variety of changes in the DNA that occurred solely due to exercise. Even the researchers were surprised by the results.
Well, we saw that about 4,000 of your genes actually changed their activity with the training, and we have about 20,000 genes in total in our genome, so about 20% changed.
A change in activity in more than 4,000 genes just through regular endurance training. The researchers were able to trace a huge network of altered genetic activity to the training effect. And it's not just the genes influencing muscle fiber development that are affected. It's also the genes that influence cellular energy, carbohydrate and sugar metabolism, and the formation of adipose tissue, or body fat. Francesco Marabita is a bioinformatics specialist. He took a closer look at the altered genes and their functions in the body. He found that the genes didn't change their regulation independent of one another. They did so in unison, within interconnected networks.
They act together. If they are co-expressed, so activated in a similar way, we suppose they share similar functions. And then the similarity is the following. You can imagine you have a network of friends on Facebook, on Twitter. When they share similar likes, when they check in similar praise, it means that maybe they have similar characteristics.
One of these networks has to do with morphology, the structure of the muscle. Yet another with cellular energy.
The fact that we, through something as simple as training, it's a lifestyle change that basically everyone can easily do. We can actually alter the activity of so many of our genes, and as well as the methylation and the epigenetics that regulate these genes.
The body has a complex gene activation program which can benefit our health. It just needs to be kicked off by regular exercise.